Let us now understand the observer's effect. In quantum mechanics, it is the most common yet misconceptualized effect in this whole field. And why it is misconceptualized? Because it's more of a measurements effect. It's not precisely an observer's effect. It has nothing to do with how you're observing it. The only crucial role that is played by something is measurement. So we are going to understand it with the help of an example. Now let's look at an example. Let's say I have a friend called John. So I have I have my friend waiting for me inside the room. So the room was dark initially. So in order to see John, my friend, I have to turn on light to be able to send light into him and being able to bounce back into my eyes so that I can know okay, there is someone, there is my friend John. Now, the moment I open the light, the moment I turn on the switch, light came, photon strike John and then reached my eyes after bouncing back from him. So I know that okay, there is John. I see him. Now, let's change this experiment slightly. Now let's snatch the small light from Doraemon's 4-dimensional pocket. So I have this small light, and with this small light I can make John very, very small. Very small. So I point this light at him and I turn on the light, and it will make John shrink and shrink and shrink. Now the John has now become a quantum particle. It's very, very small. It's not even observable with naked eye. Now John has now become an atom, and it has not much energy. It can even be pushed by other atoms. Now John atom is now somewhere in the room. I don't know where that John atom is. So for that, again, I have to turn on the light to be able to see him. I came into the room, I turn on the switch and I turn on the light. Now light came. Now here's the interesting part. The moment photons will be going to strike that John atom. Now since John is now an atom and it has not much energy to be able to encounter those photons. So each time those photons will try to hit John to be able to be bounced back from it so that I can see him. Every time a photon strike him will push that John atom away from being at initial position. So I may not even know where that John atom is. Like every time a photon hits John, will move away John atoms from its initial position. So the moment I measure it, because to be able to measure John, not observe, to be able to measure John, I have to turn on the light. I have to let photons strike that John atom to be able to perceive by me, to be able to seen by me. So every time I will be missing John to be able to be seen by me. Like every time photons striking the John atom will making him or that atom pushed away from the initial atom, from the initial position of that atom. So it will keep on happening forever. I cannot know the precise location of John's atom. That is how the quantum mechanics, the observer's effect or the measurements effect works in quantum mechanics. So you can say that the very act of measuring something or the measuring position of something prevents you from measuring its precise position, because the more you measure it, the more precise you measure it, the less precise the result you will get in return. So it's more of a measurements effect, not observer's effect, because it's not our consciousness that is playing the role here. It's not like how we are observing it, from which mind, from which dimension, from which consciousness we are observing it. It's all has to do with photons, with actual measurement device, which is photons. It is always have to do with the photons, not like any consciousness. It's always been a measurement effect, not observer's effect. And notice here, the more small an object is, the more this effect of measurement will be. That means if that John atom was like really small, very very small, and I keep making it small, so the more dislocated from its original location it will keep on getting, and as progressively it gets smaller and smaller, and it will be that its location will be dislocated from its original location or original space by the photons. And that is how the measurement effect works.